First of all, we should remember the power rule that says if y is equals to x elevated to the nth number, then y prime will be multiplied by that n number as a leading coefficient and will be having as an exponent the number n minus 1. To start, I will show you the same function, but I will rewrite it in order for it to be more simple. We divide the complex function into two parts in order to answer each one of them separately and adding both results in the end. The first part is the logarithmic function. Before starting to differentiate it, we check if it could be simplified by the use of logarithmic properties, which are three. From the three properties, we notice that we can use the second one, which turns a multiplication into a sum. We check the new formula and identify that we can still use another property, the first one, which turns the exponent of the binomial into a leading coefficient of that same binomial. In this case, will be 8x minus 3 multiplied by its exponent 1/2. So with this new function, we can now differentiate it. The rule to have the derivative of a logarithmic function is knowing that y prime is equals to u prime over u, considering u as a copy-paste of the function. We start by getting the u prime of the first part, which we get by multiplying 7 times 2, which is 14x to the 6th power, over u, copy-paste as said before, 2x to the 7th power, plus u prime of the second part, which is 8, times 1/2 over u, which is 8x minus 3. We simplified both fractions by considering that the exponents of the variables are simplified by subtracting. We add up both fractions that, as we can see, have different denominators. So what we do now is multiply each denominator by the opposite top part. To continue, we expand the upper part by multiplying 7 times 8x minus 3. We identify and add up common values. We have differentiated our logarithmic part fully, that remains as 60x minus 21 over x multiplying 8x minus 3, and we leave the other part pending. We continue with the other part of the original function, which is the trigonometric function of sine and 4x, meaning that it needs a product rule application to be solved since it has both terms of x. We know the product rule says that if y is equals to f of x times g of x that we will identify in our function, then y prime will be g of x times f of x prime plus g of x prime times f of x. We fill up the values of the product rule, remembering that f of x and g of x will only be a copy-paste of the function, while f of x and g of x prime will be known with their differentiation rules. F of x prime remains as 4 since x is having as an exponent 0. In the case of g of x prime, it will be different, since it is a trigonometric function of sine. The following rule needs to be applied. If y is equals to sine of u, then y prime will be u prime cosine of that u. Therefore, the answer of g of x prime will be 2x times cosine x squared. We get the final differentiated function by adding up the cross multiplication of the values. We search for any common factors that there might be. In this case, it will be the number 4, and we rearrange the function that will be remaining as 4 multiplying the sum of sine x squared and 2x squared times cosine x squared. To finish with this whole process, we go back and add up both differentiated functions and finally have our answer. To start my conclusion, I will emphasize the definition of the derivative, which can be approached in two different ways. One is geometrical, as a slope of a curve, and the other one is physical, as a rate of change. By completing this problem for the final math project, I noticed that different methods needed to be combined in order to obtain the final result. For example, I used the logarithmic properties, the logarithmic differentiation rule, and the product rule with the trigonometric function included. This also made me realize how in this, like most of the things related to math, you need to understand the concepts since the beginning, because if not, the results will be incorrect and the process will be harder eventually as each new rule principle is added.